Hi, my name is Kimberly Lesiana Bernard and my matrix number is 61148. So I will be presenting on the introduction and also the problem statements regarding our group project. As an introduction, the development of construction industry in Sarawak have been increasing drastically over the years. The crane is very familiar in the construction industry. It is widely used for heavy lifting and also transporting work. The crane helps to speed up the construction works in order to satisfy the public demand. However, the crane operation may not be easy as it seems like. Workers have to comply with construction hazards associated with working conditions of construction site beforehand. Thus, we are assigned to develop a crane that is able to increase efficiency and reduce safety issues in construction site. Next, we have figured out some problems regarding the project before proceeding to our crane design. Firstly, how to ensure the crane stability, mobility, and also its long-term use. Secondly, the existing site conditions or environmental factor may affect the movement of crane in the construction site. For example, uneven terrain, other moving lifting equipment, supply vehicle, and also digger. Thirdly, the changing weather condition. The changing weather condition, such as strong wind, may cause the crane to topple, and also heavy rain. Heavy rain may cause the visibility of the operator of the crane to reduce. Plus, it may cause the crane to be unstable because the platform might be muddy during heavy rain. Lastly, the crane operation will be less efficient where operation may delay due to weather conditions.
Hello, my name is Ivan Estrada Gabriel with a matrix number of 63264. Okay, for our conceptual design, our group decided to choose a hydraulic power scissor lift truck because we believe that this kind of concept actually rarely used in a construction site. Also, our group decided to only targeting for medium-sized contractor, which usually involve in housing construction site, usually the two-story housing. And this concept also designed to be able to do a multitask lifting as long as the load is not exceed the maximum capacity of this truck. Okay, next our model. This is basically our model. The dimension is 4.1 meter length times 2 meter wide. The weight of our truck is approximately 900 kilogram and the maximum capacity or the maximum load is up to 1.7 tons. Basically 1.7 tons usually the standard size of a single brick pallet. The maximum height that this truck can lift is approximately 6 meter around 2-story building construction, since we only targeting for medium-sized construction. And our truck also operate via controller with a single operator. Also, in this truck we also install hitches in front and at the rear for transportation that can be connected to any trailer via a hitch.
My name is Caroline Martin with the matrix number of 62520. Today, I'm going to present to you the material selection of a hydraulic scissor lift. Material selection plays an important role when designing a machine. It affects on many factors including the durability, reliability, strength, and resistance. A good selection of material can increase the lifetime of a machine. Before selecting a material, it is important to evaluate forces acting on each component to get the mechanical properties, and then from there we can select a suitable material for our component of a machine. Material selection of hydraulic scissor lift. Hydraulic scissor lift consists of these components. 5 components, which are scissor arm, hydraulic cylinder, top platform, base platform, and wheels. For the scissor arm, these components subjected to buckling load and bending load, which tend to break or cause bending of the component. Therefore, a recommended material is stainless steel. Moving on to the hydraulic cylinder, this component is subjected to direct compressive force and internal compressive force, which imposes a bending stress that may cause buckling of the component and generate circumferential and longitudinal stress all around the wall thickness. Thus, the recommended material is mild steel. Next, top platform. This component is subjected to the weight of the workman and his equipment. Hence, strength is required. The frame of the platform is mild steel and the base is the wood. And last but not least, base is subjected to the weight of the top platform and scissor arm. It is responsible for the stability of the whole assembly. Therefore, mild steel is used.
Hello, my name is Alfred Stewart 60224, and I am going to explain about power transmission. First of all, I'm very sorry because I cannot include my video of my face while presenting this because this laptop lag. So let's start. What is meant by power transmission? Power transmission is is for us to calculate the power needed for the each end actuators of an object, things, vehicle to function. So which means that we have to calculate a total of power each actuators so that the power source is bigger enough to support the end actuators. So here, as you can see, our project is Scissor lift truck. So our end actuators is the tires, the 4 tires, and the scissor frame. So all we need that to get by calculating the power, we can for example, if we want to calculate the power needed for the tires to move, first of all we can calculate the horizontal force dragged by the vehicle while moving forward. So we can and then we can calculate by the shaft inside here. And then by that we can find the power source. About for the scissor frame, we can calculate power. We can calculate its power while when this vehicle is static and the scissor lift is moving upwards. Then we can point upwards, and by calculating.
So here I will show some of the calculation for our design. So this is our FBD, whereby our design specification, our maximum loading is 1,700 kilogram, and also the weight of vehicle is 1,500 kilogram, and also the height of our scissor lift is around 9 meters. And then first of all, we design the link, we calculate the design of the link in order for us to get the force at the end of the link and also the force at the middle of the link, and then which is here. And then we calculate for the design of the cylinder in order for us to get the value of the diameter of the rod and also the diameter of the cylinder. Next, we do the calculation on the design for fabrication, whereby our target is to get the maximum bending moment of our design and also the width and also thickness of the scissor lift. And then By substituting all the value inside the formula of this formula, we will get the value of b and also h here. And then this is the static analysis of the scissor leaf, which needs 6 equations with 6 variables in order for us to solve and to get the value for ry1 and also ry2. After calculating, we get this value for our ry1 and also ry2, which is ry1 and ry2 is the same value. Thank you.